When I first heard about Zeno's paradox, my first thought was that was some kind of wordplay or some of those tricky questions. Then I realized that that's a real problem, which has its roots back to year 488 BC. Certain philosopher called Zeno was trying to prove that motion doesn't exist. Nevertheless, one of his famous claims was that an object should never reach the destination point because it first has to pass the half of the path, then the half of that half, then the half of that half, and so on. And because you can divide any remaining half again and again, no matter how small the remaining half is, certain object can't reach the goal because there's always a small piece left that has to be passed. Some of the philosophers claim that an object cannot even start because before it could pass the whole path, it has to pass the half of it and the half of that half, and so on. The same thing as in the first example, only in this one it is impossible even to start. I was trying to find a solution, satisfying and understandable, but without success. I mean, I know the solution, I just wanted to see if I'm right and to compare it with the other solutions. All the answers are or were in the sphere of hard philosophy, considering a space and time, which doesn't exist by the way, but that's something for another discussion. Regarding questions like, is there an infinite space and time, how they are divided, what are they made of, and so on. Some answers are offering very complex and suspicious formulas as a solution of the problem. All those things have no importance in the solution of the problem. How? This is how. The so-called paradox in fact doesn't exist. There is no paradox. The problem itself was from the very beginning mispresented, but not deliberately, but because it was presented and compared through a mathematic, but not from the inside out, then from the outside in. That was a major mistake, and a matter of fact it still is, or was, until now. For those who are perhaps confused with those halves, there doesn't necessarily have to be a half. To how many pieces the path will be divided, it's not important. The point is, if we divide that path in certain pieces, first, we will always have to pass upcoming piece, and then the next one. But because we can divide them infinitely, there will be always some pieces of the path left, so we shouldn't ever pass that path. We all know that we or any other object certainly do pass that path, and we certainly do reach the goal. Zeno himself was talking about the arrow which never hits a goal. Then there's the story about Achilles and the turtle, rabbit and the turtle, throw north, a ball released from the roof, and who knows how many examples, but they are all based on that paradox. So the right question is how to explain that. In one hand we have the logic which is telling us that we shouldn't pass the path, and in the other hand we all are witnessing that we are passing the path. The arrow hits the goal, ball for sure hits the ground, and the rabbit overtakes the turtle. There's nothing wrong in the assumption that an object first have to pass the half of the path, or any other part of it, that the half or remaining half, and so on. That is in fact what is happening. So where's the catch? Let us step first in a mathematical sphere. We all know that almost everything, if it's not everything, could be explained with the math. Every event or object can be described with the mathematical equations. So the math can be, let's say, pulled out from its abstract sphere to the real world. But the real world cannot be pushed into the math sphere. And that is the big mistake that everyone who tried to find the solution and didn't succeed made. What do I mean by that? Why I said the math is abstract. You see, when you for example divide something in a math equation, what do you really do? If I divide 10 by 2, I will get 2 totally equal halves, 2 fives. In reality, we cannot get 2 equal halves, and depending on with what we're dividing something, we'll have a waste, even if we divide something with a laser. If we divide something in a math, what does it really mean? First of all, we didn't divide anything. What we did was just an assumption. If we have a 12th piece of something, and then we divide that group into 2 groups, which are equal by the pieces they contain, then we'll get 2 groups with 6 pieces each. That's the first mistake made, to think that you're really dividing something, when you're in fact just supposing what will happen if you try to do it in reality. The second mistake is comparing reality events with math events. In math there's no motion, nothing is trying to get nowhere. How is that relevant for so-called paradox? Let's assume now that we have a car which has to pass 100 meters. As the paradox says, the car will first pass half of that length, 50 meters. When the car passes 50 meters, then we'll split the rest of the path on a half. We'll get 25 meters. Then we'll get 12.5, then 6 point and etc. meters. Every time the car will pass that path, until it reaches the point when the car's length is larger than the path that it has to be passed. And that's the crucial point in so-called paradox. Maybe you'll say now, what that's got to do with the paradox issue? Well, everything. In reality, the very length of an object is the reason that the object reaches its goal. That is why I said that in a math there's no motion. But if for the moment we imagine that there is, then the biggest mistake was to assume that something that is in the maths world trying to reach the goal is infinitely small. In that case, you will immediately get an insoluble problem. But if you consider that your object, I'd rather say shape, has a length, then that shape has to pass the path with its whole length, not just with the half or anything else. So, in reality, an object has a length, and when you are trying to find the solution inside math, you have to consider that your object or shape must have a length, like an object in reality, where there are no objects without a length, even if you're speaking of strings, a building material of the universe. So, when our car reaches a point where the divided path is shorter than the length of the car, the path is passed, because the whole car has to pass that path. The car is an object from its front to the rear end, like a ball, an arrow, or a rabbit. They all have to pass the certain path with their whole length, not just partly or just by touching the certain point. So when you say a car, you mean a whole car, not just a part of it. When you say an arrow, that means a whole arrow, not just a part of it, and so on. You see, if the car, which is let's say 5 meters long, wants to pass a path just 1 meter long, it will not pass that path if the car moves 1 meter. If the car moves 1 meter, it will do just that, move just 1 meter. But if the car wants to pass that path, then the car has to pass that path from the car's front to the rear end, with its whole length. Anything else can be considered just as a little shift of the car. You can say that the path can be cut in half many times more, and then the car has to pass every little piece of that path in the way I described above. Yes, it can, and yes, it could, but to do that the car would have to go backward, which is not predicted by the quest from the beginning. So the solution of the paradox is the very length of an object. Because of that length, everything at the end reaches its destination. From the starting point, any moving object is splitting the path into smaller pieces, and then when the very length of an object is larger than the remaining path, an object overtakes the remaining path. Thank you for watching this video.
Oi, 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 oi.